Hi students, this video is regarding the chapter triangles of class 10. Okay, see the main basic concept of this chapter is we discuss about the similarities of the triangles. Similarities. Why similarities? Because till your ninth grade you have applied and you have learnt the congruency properties and you have applied many congruency properties for the triangles and you did many proofs also. But here you might have learned about the similarities but you might not have applied many similarity concepts. Here in 10th grade in triangles chapter you will apply similarity properties along with the theorems, like how you had in your 9th grade AAA, SS, triple S and SAS properties of congruency. The same properties are also there for similarities and the theorems are also there, but the theorem proofs are not required. We apply only the concept of the theorems. Okay. Now what is the similarity and what is the difference between similarity and congruency? I'll tell you. See, congruency and similarity. What is the difference between these two? Congruency and similarity. See, congruency means same shape and same size. Similarity, same shape, not necessarily to be same size. This is the concept of similarity. That means suppose if you see two figures in triangles, something like that, these two triangles are said to be congruent if all the sides are equal. Also all the angles should be equal. Okay, that means both the triangles will have the same sides, same length of the sides and also same set of angles, corresponding angles. But in the similarity condition, what happens, all angles will be same. That means corresponding angles will be same, but the sides are not in the same size. That means the sides are not of the same length. So in similarity, what happens? The figures will not be of same size, but they will be of same shape. Shape will be same, but not of the same size. Not only in triangles, it happens in many cases. See, suppose if you see the circles, this is a circle, and this is a circle, this is a circle. These are all of same shape, but not of the same size. So all circles can be taken as a similar circles. We should not apply the congruency for the circles. Congruency will be applied only when it is of same shape and also same size. That keep it in mind. Okay, right. Now in different types of triangles, how the triangles will be similar? Different triangles will be similar. The triangles will be similar by default only if they are equilateral triangles. By default the triangles will be similar only if they are equal. See why only equilateral triangles? Because in equilateral triangles what happens? All the angles will be equal and all the sides, both the figures will have the same shape. Both are triangles and both will have the same shape. And one more property is there for polygon, not only for triangles, for polygon. So let us forget about the congruency. When we talk about the similarity, not only in triangles, even in the case of polygons. Suppose if you take two different figures of the same shape but not of the same size, these figures, not only triangles, these figures, or we say that polygon. A polygon means it's a closed figure. A polygon is said to be, two polygons are said to be similar if the corresponding angles are equal. If the corresponding angles are equal and corresponding sides are in same proportion. Same proportion means same ratio. See, suppose if both are squares, that means sides angles are 90. Suppose if this is a square of side 2, 2, 2, 2, and if this is square of side 6, 6, 6, 6, what is the ratio of the corresponding sides? 2 by 6, 2 by 6, this by this, 2 by 6, this by this, 2 by 6. So all are equal, all are equal. Same proportion means this. That means all the angles are same. That is the reason why it is in both are in same shape. But all the sides are different. That's the reason why they are both are in different size. But the sides are in the corresponding sides are in same proportion. The ratio of the sides, if you compare corresponding sides, then they will be in the same proportion. Then the two figures are said to be similar. Not only in triangle, not only in the case of squares, it happens in the case of rectangles also. But the only condition to satisfy is in a polygon. For two polygons to be similar, or for to satisfy the condition of similarity, the polygons the corresponding angle should be equal. And the corresponding sides should be in the same proportion or same ratio. Okay, this is the main basic concept for similarity. Okay, now let us go to first exercise of triangles. They are given some fill in the blanks for similarity conditions. What are those? Let us see. Triangles exercise 6.1. Now the first question. All circles are similar. They are not congruent. Why they are similar? They are not congruent because they don't have same shape. They may not have same shape. It is not necessary to have the same shape. Then we say that they are similar. They look similar. Is it right? Because they all are in same shape. Okay. Second one. All squares. What about all squares? These are also similar, no? Why all squares are similar? Because in square the corresponding angles are 90, 90, 90, 90, and the corresponding sides, if you take the proportion, the ratio of the sides, it will be same because the square will have all the sides same, the other square also will have all the sides same. If you take the ratio of the corresponding sides, it will be same. So we can consider all the squares are also of a similar. Third one, all dashed triangles are similar. I told you, when you take the example of a triangles, all equilateral triangles are similar by default. Why? Because in equilateral triangle, what happens? Corresponding angles will be 60, 60, 60, 60, no doubt in that. So both will be in the same shape. And when you take the ratio of the sides, when all the sides are equal, when you take the corresponding sides ratio, then also they are in equal proportion, but not in equal. So you can consider only in the case of all equilateral triangles. By default, you can say that all the equilateral triangles are similar. All only equilateral triangles are similar. Right. Next question. Two polygons, I told you just now the definition. Two polygons are similar if the corresponding angles are equal. Two polygons are said to be similar if corresponding angles are equal. Angles should be equal, and corresponding sides should be in same ratio or same proportion. Same ratio, or it should be in same proportion. Okay, next question. Give the different examples of a pair of similar figures and pair of non-similar figures. Okay, I'll give the example. Let us rub this. Pair of similar figures. I gave an example. I don't take right angle triangle now. I take some other triangle, some obtuse angle triangle. Similar, for similarity, I am taking like this. Example 1. Example 2, 4, 3, 6, 5, 10. See, I have taken both figures in such a way that the angles are equal. So I take this as 30, this as 60, no, 70, this will be 180. This also 30, 70, 80. This you can take it as an example of similar figures. See, the corresponding angles are equal, and when you take the corresponding sides, 2 by 4, 2 by 4, 1 by 2. Next, 3 by 6, that is 1 by 2. Next, 5 by 10, 5 by 10, this is also 1 by 2. The corresponding sides are in same ratio. So these are considered as a similar figure. Triangle. Give two different examples of pair of similar figures. Okay. Next, one more example. What you can take? Shall we take the example of a square or rectangle? So let us take any quadrilateral. Any quadrilateral. Okay. So I take a quadrilateral like this. One more example. Example 2. Example 2. Just take bigger size. Take the angles as 30, 120, 140, 150, 60, 120. We take this also like that only. We take little obtuse ones. So shape changed like this. Okay. It looks little similar. Okay. The angle will be 120 here, 30 here, 60 and 150. 150. See, all the corresponding angles are same. Sides if I take 2 here, 6 here, 3 here, 9 here, 3, 4 here, 12 here, 5 here, 15 here. See, this is an example of a similar figures. Similar figure. It happens not only in the triangles. It happens in all the polygons. Polygons means closed figures. See what is happening here. Corresponding angles are same, and corresponding sides. If I take 2 by 6, 2 by 6, it is 1 by 3. 3 by 9, 3 by 9 is also 1 by 3. 4 by 12, 4 by 12 is also 1 by 3, and 5 by 15, 5 by 15 is also 1 by 3. So you can take this figure, this pair as an example of a similar figures. Okay. Next, you want non-similar figures. Non-similar figures very easy. You take an equilateral triangle and you take a right angle triangle. ABC, PQR. These are non-similar. Why non-similar? The corresponding angles are not equal. Corresponding angles are not equal. And one more thing. You take a square here and you take a rectangle. 2, 2, 2, 2. 2, 4, 2, 2. 2, 4, 2, 4. A square and a rectangle. These are also non-similar. Why non-similar? Corresponding angles are equal. No doubt corresponding. But what is happening? Corresponding sides are not in the same ratio. See, 2 by 2, 1. But when you take this one, 2 by 4, 1 by 2. That means the corresponding sides are not in the same ratio. See, for two figures or for two polygons to be similar, the corresponding angle should be equal and the corresponding sides should be in the same proportion. So that's what is not happening in these two cases. Okay? Right. This is the right angle and this is equilateral. Very simple example for non-similar figures. Okay? Right. Last question. They have given some figure and you are asked to check whether these figures are forming a similar pair or not. Let us see. I draw that. They have given something like which is not a square. Don't call it as a parallelogram, but it is not a square. PQRS, it looks like a rhombus also because all the sides are equal. And ABCD, it is also a square. It is a square given here. ABCD 3, 3, 3, 3, and it is 90, 90, 90, 90. 90, 90. See, these two are not similar. Why these two are not similar? Because the corresponding angles are not equal. But what is satisfying here? The corresponding sides in the same proportion. See, 1 by 5 by 3. What is happening? It is 1 by 2. 1 by 5 by 3. 1 by 2. That is happening in all the cases. 1 by 5 by 3, 1 by 2, 1 by 5 by 3, 1 by 2. Here the corresponding sides are in the same ratio, but the corresponding angles are not equal. So it is not similar. That means for a similar condition, both the conditions should satisfy. What are those two conditions? The corresponding angle should be equal and the corresponding sides should be in the same proportion or same ratio. Alright guys, all the best.